Hi everyone, we're going to look at transformations of functions. So our transformations are the four transformations that we typically use are translations, rotations, reflections, and dilations. Those are what we saw in the geometry unit in 8th grade, and you'll see more of that in 10th grade geometry as well. Those same transformations are also done to functions. We did look a little bit different. We use a little bit different terminology, but it's the same kind of basic principles. So for the first one here, we've got g of x equals negative the cubed root of x minus 2. I want you to always think of these transformations using order of operations, as always. So look at where x is and start from there kind of out. So with x, there's no numbers being added or subtracted inside where x is. So there's no horizontal shift here. Because if it was, say, for example, x plus 2, in the cubed root like this, minus 2, that would be a shift left 2, which is kind of backwards. You would think plus 2 would be a shift right 2, but it's backwards, and I'll show why at the end why that is. So for this one, there's no horizontal shift, but there's a negative out front and there's a minus 2 here. So again, you got to think order of operations, what would come first? Well, the negative is being multiplied essentially, because it's like a negative 1 times that. So we're going to write down that one first. So the first thing is actually a multiplication of negative 1, which is a reflection over the x-axis. That's what the negative 1 does. Think about why that is. Think of an easy example like x squared. If I made it negative x squared, it flips over like that. Because all the y values just become negative. That's why it's a reflection over the x-axis, because it flips down, and all the y's just become negative versions. So for the negative 2 on the end, that's like the last step here. That would actually just shift everything down 2. So it was already flipped over the x-axis, and now all those points are shifted down 2. So that's a translation, I should say. It's a translation down 2, or we can call that a vertical shift down 2. Same thing. This one over here, we're going to again start order of operations. We've got parentheses. So the x plus 3 there is going to happen first. The plus 3 is, again, kind of backwards from what you'd expect. It's in there with x, so it's going to be the opposite of what you'd expect. So plus 3 would actually go left 3. So the first step here, translation, or translate left 3. We also call that a horizontal shift, left 3. And then the cubed on the outside, that's just part of the parent function. The parent function here would be x cubed. G of x equals x cubed, or f of x probably should call that. This one's g. So that's not a transformation. It's just part of the actual function itself. The only other transformation here is the negative, which again reflects it over the x-axis. And the parent function for the previous one was the cubed root of x. In order to figure out the parent function, typically look for what would it be without any numbers, and that's basically what the parent function is going to be. The only kind of trick to that is the numbers here in the powers. We do need those numbers, so it's not really a guaranteed to take away all the numbers you get the parent function, but that's a little tip. For down here, for these a little more complicated examples, we're going to again start where x is, order of operations. This would be like parentheses to the 1/3 power, or the cubed root there. So we're going to do that first. X minus 2 would be a translation right 2. Again, it's kind of backwards because it's inside there with x. Or we can call this horizontal shift right 2. And then we would go order of operations. What would come next? The 4. So the 4 would be, we call this, it's kind of like a dilation in a way. We call it a vertical stretch because all the y values are being multiplied by 4. So this would be times 4. And then we've got the plus 1 left. That's a vertical shift or a translation up 1. And the parent function would be, again, this would be the cubed root of x. For the last one here, the parent function would just be the absolute value of x, which makes everything positive when we do absolute value. And then our transformations, our first one would be the 2, because it's closest to x. It's our multiplication, which comes before the addition. So it's a vertical stretch times 2. And then we've got the plus 3 there, which would shift it up 3. So this is a vertical shift or a translation. It's the same thing. Up 3. So there's a little trick there. Why are the ones that are inside here, like the one on the left, why did this move left and why does this one move up? Why is the vertical one kind of what we'd expect, whereas the horizontal one is kind of backwards? So let's use another example to think about why this is. So if we use, for example, f of x equals x squared. This is a pretty good example to look at why it's backwards. If I used f of x equals x, it wouldn't be as clear. So say we want to shift this right 2. So what we're going to do is actually do g of x equals x minus 2. So why does that shift it right and not left? Well, if you were to solve for x here, say we call this y equals x minus 2 squared, and you want to solve this for x, you do the square root. So square root of y would equal x minus 2, and we should have plus or minus in there, because technically there are 2 values here. And then if you were to solve this for x, it would be plus 2 and plus 2. So x would be 2 plus or minus the square root of y. What would it be before? Well, if you look at the original, if we called it y equals x squared, and we solve this for x, square root, plus or minus, x would be plus or minus square root of y. So you can kind of see here why this is backwards. So right 2 makes the x's 2 bigger than what they were before. Because if you take what it was before and add 2 to it, we get the new x's. And that's why right 2 is actually backwards on the inside, because everything's in terms of y. If you were to solve in terms of x, it would be more what you'd expect, because it's not, functions are not written x equals, they're written y equals. So the y one essentially makes more sense, like up here, up 3, because this is y equals. So the y was 2 absolute value of x, and then we added 3 to it, so the y increased by 3. Whereas for the x's, it's backwards, because you'd have to solve for x to see what you'd expect. The right 2 is a minus 2, because then when you go to solve for it, it actually is a positive. So that's it for transformations of functions. Hopefully that helps.